Welcome students. In this lecture, we are going to discuss our example of class interval summarization, which is the third example in this series. And this is the data set that you are provided with. It is precise to two decimal places, as we can see. Compare it with the previous data sets that we had been working with. This was the last one. It was precise to one place after the decimal, and before that, there was no precision in the data set or for the integer numbers. So this is the last example that we are working on now, and this is the data set. So let's be quick with it. The number of groups or the number of classes that we have, as we all know, is basically found by log n upon log 2. The total data set size can be easily found by making the product of total number of rows by columns. We can see we have 1, 2, 3, 4, 5 columns and 1, 2, 3, 4, 5, 6 rows. So the data set size is 6 by 5, which is 30. So the number of groups can be found by log of 30, and then dividing it with log of 2, and this comes out to be 4.90. So what we have done over here is found the ratio of log 30 by log 2, and this is 4.90. Definitely we are going to round it up to the next higher integer, which is 5. So we have got total 5 classes in the data set. Next comes the range, and for the range we need max and min value difference divided by total number of classes which we have just decided, and so we can put it over here 5. And finding the maximum value and minimum value is very easy. We don't need to arrange the data in the ascending order. We can just do it like this. So in the first column, the highest value that I can see is 64.10. And if I'm going to compare this value with the rest of the columns, if I can see any value greater than this, then I'm going to discard this one and take the newer one, or I will keep it if I don't find any value greater than 64.10. So we can see there's no value greater than 64.10 in the second column, but in the third column there's a value which is much greater than this, and this is 67.25. And in the fourth column we got another value greater than 67.25, and this is 67.29. Then in the last column there is no value greater than this one. So the maximum value that we have in the data set is 67.29. We are going to subtract 67.29 with the least value, and the least value in the first column, which we can see, is 36.07, and there is no value lesser than 36.07 in the second, third, fourth and fifth columns. So this is going to be our least value, 36.07. And when we find the difference between the two, that is 67.29 minus 36.07, and then divide this difference with 5, which is the total number of classes that we have decided, we get 6.24. Now this is a crucial point over here. 6.24. I'm not going to round anything, I'm just keeping the results as they are. Now what is going to become our class height? Before answering this question, let me take you back to the previous example, what we did over there. See, we had 0.516 as the calculation result, and our data was precise to one place after the decimal. So we just looked into the first place after the decimal, that was 5, and we rounded only that value to the next higher integer, which was 6, and so the total result became 0.6, and we kept 0.5 as our class width for getting any value which was written after 5. And this is what we are going to do over here as well. Our our data set is precise to two places after the decimal. So we are going to pick the last second place after the decimal, which is 4, and round this 4 to 5 and neglect any value afterwards. So what I mean is this, that class height would become something like this. So it becomes 6.25, and 6.24 will become our class width. We will neglect this 4, which is written as at the third place after the decimal. We are going to completely neglect it, discard it rather. So let's start filling this class interval table so we can better understand the things. So 36.07 is our lowest value, so we start with it, and we are going to add 6.25 to 36.07, 36.07 plus 6.25, and this becomes 42.32. So 42.32, and then this becomes the lower limit of the second class, and to it we are going to add 6.25, and we get 48.57. And sorry, let me correct this typo. And again we are going to add 6.25 to 48.57, and this becomes 54.82. And we are going to add 6.25 to 54.82, and we get 61.07. So all our lower limits of all the classes are filled now. Now we are going to add 6.24 to 36.07, and so the upper limit of this class becomes something like this: 42.31. Likewise, 42.32 plus 6.24 gives an answer which is 42.32 plus 6.24 becomes 48.56. Likewise, 48.57 plus 6.24 becomes 54.81, and 54.82 plus 6.24 becomes, so it's 54.82 plus 6.24 gives 61.06, and 61.07 plus 6.24 gives an answer which is 67.31. And so this fills our first column. Next come the frequencies, which are the values within each class. So 36.07 to 42.31. So the trick is that first look for the integer part of the value and then look for the decimal part. Otherwise we might get confused. So 36.07 over here. So we have got a value in this interval. So we mark it with a color, and till 42.31. So I'm looking at the integer part. So we have got 39, which will definitely part of it. So I don't need to worry about what is written after the decimal. And then 38 should also be part of it. So whatever written after the decimal can be taken in this interval. And 36 to 42. So 36 to 42, no other value. 36 over here we have got 35, sorry, 36.85, and 36 to 42, this should also be part of it, which is 41. 36 to 42, this 37.29 should be part of it. Then 36 to 42, 38 should be part of it, and no other value in this column. 36 to 42, 39 should be part of it. 36 to 42, now there's 42.89, but we have limited to 42.31, so seems that that's it. So one, we now count all the yellow color cells. So 1, 2, 3, 4, 5, 6, 7, 8, and the frequency comes out to be 8 over here. Then 42.32 to 48.56. So 42 to 48, the integer part, 42 to 48, and here we have got, so it's 48.25. So for the next class I'm picking another color. So 42 to 48. Now you see, we missed this one. So 40.15 was missed because it is not part of this class, but definitely was part of the previous class. So I'm going to mark it with the yellow. I'm going to increase this 8 to 9. And we'll see if we miss other values as well. So coming back to our second class, 42 to 48. 42 to 48. 42 to 48, this should be over here, and we mark it with red. 42 to 48, this should be over here, and we mark it with another red. And 42 to 48, over here we mark it with red. 42 to 48. See, there's another number which is not part of this interval but part of the previous one, and we missed it. So I'm going to mark it with yellow. So we see how we can make mistakes. It's also important to learn that where we make the mistakes so that we may not make them in future. So I'm teaching 9 to 10 because we missed another cell of this class. So coming back to the second class, 42 to 48, 42 to 48. This one 45 having an integer on part, 45 should be part of it. 42 to 48, and these last two should also be part of it. So let's count the red color cells. We have got 1, 2, 3, 4, 5, 6, 7. So 7 are here. So let's see if they are actually 7 as well. Now 48 to 54, 48.57 to 54.81 is the actual value. I'm just looking into the integers so it is easier for me. 48 to 54. So 48 to 54, this should be part of it. So we mark it with blue. So 48 to 54, none of these cells. 48 to 54, none of these cells but this one. So at the moment 2 appear to be over here. Like 54 to 61. Actually the values are 54.82 to 61.06. So 54 to 60, sorry, 54 to 61, yes. So we have got 154, 55.80. Sorry, we need to mark it with a different color because it's a different class. So I'm changing its color. Let's take this orange one. 54.82 to 61.06. So this cell should not be part of it. This one as well not. But this one 60.29 should be part of it. So 54 to 61, 54 to 61, and this one as well should be part of it. So 1, 2, 3. Overall, the frequency comes out to be 3. And then 61 to 67. So all the remaining should be coming in this last class. Sorry, I marked with the wrong color. Let me correct the color. So 61 to 67. I'm just looking into the integer parts because it becomes easier this way. So 61 to 67. This is a good method. I prefer marking them with colors or shades because at the end, no bricks or no cells should be remaining without any color. If they are remaining, then it shows where we have missed and then we can easily rectify them. Like over here, we can see this cell 58.95 should have been part of the fourth class which we missed. So since we missed this one, so I'm going to mark it over here, but so 54.8 to 61.06, 54 to 61, right? And I just want to correct this one as well. The font color should have been not green, rather it should have been blue. Sorry, the font color should have been blue. Oh yes, it's better now. So 54 to 61, 54 to 61. Actually, uh, there's some mistake with the colors, so I'm going to rectify them. But never mind, I'm going to rectify them. And the last, first, make it four. Let me make it four. And the last cell that we are going to use 61 to 67. Uh, there's a mix up of the colors, so I'm going to change it to green so things can be rectified. Yep, so it's better this way. So 61 to 67, I'm going to change them with green. 61 to 67, I'm going to change them with green. These are the mistakes that we normally do. What I mean, sometimes they happen just as they are, and sometimes voluntarily or involuntarily. But that's a good part of it, that when we are working alongside, then we can see that where we actually make the mistakes, and this actually helps to not to repeat the mistakes in the future. So this seems okay now. All the bricks, all the cells are filled, and in the last cell, the last interval, sorry, the number of cells or the frequency comes out to be 1, 2, 3, 4, 5, 6, 7. So let's see whether we are on the right track. Let's add all the frequencies and then see that are we on the right track or not. So it's 10 plus 7 plus 2 plus 4 plus 7, and this comes out to be 30, and this is quite sensible answer because 30 was the total frequency or the total dataset size as well. Now the relative frequency, that is the probability of each cell to appear as an outcome, or the value from each cell to appear as an outcome, is 10 by 30 for the first case or for the first class, then 7 by 30 for the second, then 2 by 30 for the third, then 4 by 30 for the fourth, sorry, and for the last one it is 7 by 30. Next come the cumulative frequency column. We are going to cumulate or add up the frequencies. So for the first case cell, it is 10 because there is no frequency previous to it. Then 7 is the frequency of the second class. We are going to add with the previous one, and this comes out to be 17. Similarly, 2 plus 17 is 19. Likewise, 4 plus 19 is 23. And 7 plus 23 is 30. Again, sensible answers. 30 should match with this one. The class boundary, the jamming factor to integrate the classes. It's again the same way to do it. We are going to subtract the lower limit of second class, which is 42.32, with the upper limit of the first class, which is 42.31, and divide the answer by 2. So let's do this calculation. So 42.32 minus 42.31 and divide by 2 gives 0.005. The answer is 0.005 or 0.005. This 0.005 is going to be subtracted from the lower limit of the class. LLC is for the lower limit, and added to the upper limit of every class. ULC is for the upper limit. So it's a simple thing to do. And let's quickly do this thing. So 36.07, which is the lower limit of the first class, minus 0.005 gives an answer which is 36.065, and then 42.31 plus 0.005 gives an answer which is 42.315. Likewise, 42.32 minus 0.005 gives an answer which is 42.315. 2 48.56 plus 0.005 gives 48.565. Similarly, 48.57 minus 0.005 is 48.565, and 54.81 plus 0.005 is 54.815. Likewise, this goes something like this: 54.815 to 61.065, and then we have 61.065, the lower class boundary of the last class, and then to 67.315, and 0.005 is added to 67.31. So we can see that the number at which a class ends is the same number at which the other class or the next class is beginning. And this is the idea of the class boundary. And also note this thing, that as we did in the previous examples, our data set was precise to 2 places after the decimal, and the class boundary is precise to 3 places after the decimal. In the previous examples, see this thing, that our data was precise to 1 place after the decimal, and class boundary was precise to 2 place after the decimal. And in the first example, the data had 0 precision, and the class boundary was precise to one place after the decimal. So this is a systematic way of doing the things, and it helps us to give us the feedback that whether we are on the right track or not. Last is the class mark, which is the middle value of the every class. So we are going to add the lower and upper limit of every class and divide it by 2. So for the first, it is 36.07 plus 42.31, sorry, 42.31, and divide this by 2, and we get 39.19 as the class mark for the first class. Similarly, 42.32 plus 48.56, the values for the second class, divided by 2, and we get 45.44 as the class mark for the second class. Then 48.57 plus 54.81, the values for the third class, divided by 2. When sum them and divided by 2, we get 51.69. Then we have 54.82 plus 61.06 and divided with 2, we get 57.94. And lastly, for the last class, 61.07 plus 67.31 and divided by 2, we get 64.19. And that's how we fill up all the class marks for the individual classes. And this is the way we have summarized our data set in the form of the class interval table, filling up all the columns. I hope this is understandable to everybody. Still, if there are any problems, any queries, any confusions, you can write down in the comments and I will get back to you. Thank you very much. Thank you for staying with me. Stay safe.